Okay. I just have to wait for this to load and then I can close it. Perfect. All right. I don't know why this thing shows up on my screen share. This seems like this is always such a silly thing to do. Okay, now I got a nice clean screen. Welcome. No, I don't. What happened? Oh my God. That's embarrassing. All right. Welcome to August, everybody. My birthday was 2 days ago, actually. That's other news. I'm now 40 years old. Welcome to August. If you are joining us from out of town and you didn't hear me before, jump in the chat. Let us know where you're from. Let us know what you're working on, what you're struggling with. If you have any questions for the community. Also, regarding community, if you haven't joined our Slack group that is always full of smart folks, that is devopsto.slack.com here in the middle of the slide. And we post all the notifications for upcoming meetups at DevOpsTO on Twitter. That's the other handle here. And we would love to we'd love to see you and talk to you between meetups. The meetup is really just something that we do to share things throughout the community, but there's always conversations happening on Slack. So I want to introduce and thank CloudBees. They are a new sponsor for 2021. They've been very generous to support the community, which helps us do things like events, pay for all the infrastructure that sits behind the scenes of this. And so we're very pleased to have them. They have DevOps World coming up in September. So registration is now open. The agenda will be announced at the end of August. And that's always a really good event. You know, it covers everything from leadership to technology beyond the CloudBees ecosystem. It's not just about CloudBees, it's kind of about DevOps in general. So there's always something to learn about something inside of the DevOps ecosystem. We're also continue to be sponsored by the wonderful JFrog folks who've been with us for, I think, a year now, which is awesome. I think that's a record for sponsorship. We usually get people wimp out before sticking with us for too long. But JFrog has been wonderful to support us. They've been excellent partners. Shout out to Ari. He's a big fan of the Toronto community and a consistent supporter of this effort. Very pleased to have him. I mentioned my book. I would love to hear your feedback on it, whether it's something that you are willing to try in your teams. If you tried it and had trouble and there's something I could help you out with. It's a really quick and easy read that introduces some collaborative mapping techniques that you can use with your team, no matter what your team is and whatever your position is, to understand your situation, your challenges, your goals, and get you from a problem to a solution in a very clear and actionable way. So this is totally free. There's not even a sign up form for this. This is the direct link. So go check that out. I would love to hear from you. Send me a message in Slack if you read it, if you hated it, if you think I missed something. I would love to hear that and have more conversations about this idea of collaborative mapping, because I think it's really, really something that's missing from DevOps. So instead of Kaspar, we have today Luca in his place. He's going to be delivering the exact same talk about developer self-service and portals. He's also from Humanitec. And with that, I am going to hand off to him and let him take over the show. Welcome, Luca.
Yeah, thanks, Steve. Hey, everyone. Let me share my screen. I apologize for Kaspar. He's just somewhere in Germany with a really bad internet connection. And so we thought it's probably best if I do it. So hopefully my connection holds. Let me present this. Can you see it? Do you also see this?
I can see, it looks good. I don't see any
Oh, you don't see the
artifacts or
thing on
anything.
top, right?
Yeah, luckily.
Okay, good.
That's great.
Okay, good. But now I'm stuck with, okay, good. Yeah, so hopefully my connection holds. If it doesn't, just let me know if I'm frozen. And if you have any questions, just jump in. Hopefully we can make this as conversational as possible. So as Steve was saying, I'll talk a little bit about developer platforms, internal platforms, internal passes. People have a lot of names for them. We at Humanitech are trying to sort of establish a term that's internally developed platform, just to define a category. As internal platform is a little bit vague. Developed platform or portal tends to be something else. So anyways, happy to get into the weeds of that if you guys are interested. But just to give you a little bit of a kind of like structure of what I'm going to talk about. First, I kind of want to cover why internally developed platforms or IDPs matter. Then talk about what it is, and then I can show a few examples of how we think about things at Humanitech, for instance. And then we can discuss open source tooling and like different ways of building IDPs. So why does it matter? Well, most people think that Peter Bruegel the Elder in 1562 wanted to describe the triumph of death, maybe, but actually, this is what we think is quite similar to the ops or DevOps setup of a lot of teams that we talk to. And so if you go into the details, you'll see, armies of YAML files marching towards the ops teams, deploys failing everywhere, the ops completely overwhelmed by the armies that are surrounding them. And on top of that, CTO comes in, asks if you can clean up some pipeline scripts, also decides that by Christmas, you're going to be multi-cloud. And then when you thought you had figured it all out and you're finally grabbing a beer at 8 p.m., pager duty wakes you up and you're like, no, come back to work, baby. So anyways, if you're in ops, you're probably familiar with some level or some degree of these problems. We certainly see it happening in a lot of teams and a lot of setups, a combination of these at least. And the sort of premise of that is the kind of like the idea of you build it, you run it, that was started to be popularized in 2006 by Werner Vogels, when we all went cloud native, and all of that good stuff, right? And so the idea there was, you build it, you run it, developers are finally free to run their own apps and services. The reality set is that once you pair that mindset with a tooling landscape that is constantly exploding, especially in larger teams at enterprise level, it means that to run your apps and services independently, you actually need to touch, scripts, 10 different tools, and then you end up just, relying on ops. And so all of this ends up, slowing you down, and that's really dangerous. So we had an interesting interview with, and I'm going to share the slides after, I guess Steve will, but we had an interesting chat with the Jason Werner, who's the CTO of GitHub, where it really drills down the importance of speed and sort of like deployment frequency, and how that really makes a difference between the average team and sort of like the top performers in the industries. And you can see that across a lot of different sort of like surveys and studies. The top 25 sort of like highest velocity teams are killing competition basically. And so why don't engineering teams usually ship fast? So if we have to summarize the sort of the Peter Bruegel The Elders painting, well, usually it's a combination of these factors, right? It's dependencies on ops to run your apps, to run a bash script, a manual script of some sort. It's the fact that ops end up overwhelmed with ops overhead tasks that they need to deal with, and workflows that might have worked when you were 10 people, 20 people, 30 people start breaking as you scale up and you're onboarding developers on a weekly or monthly basis for the larger teams. And then in general is this concept of extra cognitive load that is sort of imposed upon developers. So now just to do a simple deployment, you have to understand infrastructure as code. You have to understand, Kubernetes or Helm charts or whatever, right? And so this is what slows people down, what slows teams down, and what creates all these issues. And so the response of top performers like a GitHub, like a Spotify, and so on, is enabling developer self-service. And by enabling developer self-service, so letting developers interact autonomously with your setup, with your infrastructure, you eliminate these dependencies on ops, and then you lower the costs and massively reduce the cognitive load, which is really kind of like the key issues here, right? Again, I'm happy, I'll share this if you guys want to sort of like dive deeper in the data, but we recently also spoke to the CTO of Puppet, and they just published a couple of weeks ago the latest State of DevOps report, the 2021 one. And in there, you can also see they also highlight the importance of sort of internal platform teams, especially this year, and then really showing the results of using these two sort of like pillars to enable developer self-service and what the benefits are. And so you really get incredible multiples on your deployment time, on your deployment frequencies, by at the same time lowering your lead time, your MTTR, and so on. And so the way sort of top performing engineering teams enable developer self-service is through internal developed platforms. And again, this is not a new concept. They've been around for 5 to 10 years at the sort of like at leading tech organizations. But we're now seeing through a combination of especially open source tooling, a lot of teams building these in-house and having the possibility of building them, whereas a few years ago, it would have just been too expensive in terms of manpower, in terms of resources that you had to throw at the problem. Not just to develop one, but especially also to maintain and keep shipping features and so on. And so I'm now gonna go a little bit more in depth into what an actual IDP is and what it looks like. So the way we think about it is an IDP is something that gives you a developer experience that's comparable to one of a platform as a service. So if you're familiar with something like Heroku, it could be a similar DevX, but as opposed to a traditional password in Heroku that usually limits you to a very specific tech stack, a very specific set of tooling, an IDP is flexible to work with your setup, and it can evolve as your setup matures. And the key idea is that developers are, the sort of like the developer workflow becomes coding in your IDE, doing a Git push, and then, probably in most cases, you don't even really touch the IDP because it's not like every day you need to interact with the infrastructure, provision a database, or spin up a new environment. But if you have to do so, you can do that through the IDP layer that sits between the developers and the infrastructure and sort of shields them from the underlying complexity of their setup. And so looking at kind of a little bit more in depth where the IDP sits. So it usually it's a combination of kind of like your CI/CD setup, but basically what we see in most teams, it sits right after the CI pipeline, and the input usually are built images, and if we want to take a step back, why does it sit after the CI pipeline? Well, traditionally version control CIs have been problems that have been fully solved in the industry. There's plenty of solutions there. The ecosystem is very mature. The issues kind of comes here after CI, when you again need to enable your developers to autonomously run their applications and services. And so an IDP basically has the key as sort of like three key components. A sort of like a core API service that glues all the different bits and pieces together and allows ops team to set baseline templates that developers can apply changes to. So that's the app configurations bits. And then whenever a developer needs a resource, a database, DNS, and so on, to deploy their applications, the IDP, the sort of the core API layer figures out what the what resource they need, it provision it, and it feeds it back to the third component, which is a self-service, UI, CLI, API, however, the sort of like it best fits in the developer workflow. But the key ideas and the key sort of like pain points that IDPs address really are application configuration management effectively and infrastructure orchestration. And so if you look at infrastructure orchestration, this is what we see happening in most teams. So you'll have a combination of manual and bash scripts. You'll have, Terraform, Pulumi, infrastructure as code scripts, and so on. And, especially as the teams sort of grow and scale, complexity kind of, scales and non-linearly. And so you'll have a situation where, developers need to touch some ISC script that they're kind of afraid of because they don't want to screw things up. Otherwise, they need to wait on ops. That creates all sort of bottlenecks, frustrations, and so on. And so what the IDP allows teams to do then is basically say, hey, you basically have a platform or an API layer between the development team and the infrastructure. Whenever the development team needs a database, a file storage, or whatever, they can self-serve that through the UI or the CLI. The API layer goes and provisions that through drivers that are open source and feeds it back through the API layer, through the UI and CLI to the dev. And all of this within a context that is governed by the ops team. So a lot of times when we explain this, ops sort of freak out because it's like, oh, but then what do you mean my developers can autonomously interact with our setup? Through the API layer, you can enforce an RBAC and RBAC model to make sure that you actually gain a lot more visibility and control over who deploys what, who spins up what a resource or what environment that you would normally have just by letting people, fiddle with ISC scripts, and then it becomes really hard to track changes and who did what when. And similarly, this is a case that's specific to Kubernetes, but you see this in app config management, where again, development teams need to interface themselves with a combination of Helm charts, kube control, and so on. Again, all sorts of bottlenecks ensue. And what an IDP basically allows you to do is saying, hey, you as the op can set a baseline configuration template, basically, which is just a regular YAML file. And then at runtime, when a developer wants to deploy, they can apply changes to that baseline through the UI or CLI API, and a new manifest is created that is then deployed onto the clusters. And so that way it becomes really straightforward to track changes and and see who did what and what, and then being able to do this and rollbacks and manipulate those deployments. The same with code, basically. It's important to mention that this doesn't restrict developers in any ways. So it's also a fear that we hear a lot from the developer side, where it's like, hey, now you're locking me into a specific set of rules or path that the ops team sort of like predefines for me. And so obviously there is the usual kind of opinionated versus unopinionated trade-off. But the reality set is, again, depending on the permissions that ops team can specify in the RBAC model, you can allow developers to, for instance, script everything themselves. So if they are familiar with YAML or any sort of configurations files, they can just write that themselves to express exactly what they need. And so there is a total freedom in how you want to deal with application configurations and the infrastructure orchestration piece as well. But the reality side is, what we see is this is really, in most cases, a sort of a psychological barrier. In 99.9% of cases, actually, they will just, developers will tend to just follow the golden path. And so to wrap up kind of the self-service bit, this is what we mean when we talk about developer self-service specifically, is the ability now for a developer to independently spinning up environments, adding different images from different registries, and you can sort of like get notified from the different CI pipelines and so on, provision different resources like DNS, storage, and so on, and then deploy. And you can do all of that independently from sort of a central ops team. At the same time, once you have deployed, you can also then manipulate those deployments really easily, again, fully independently. So you can do rollbacks, you can do diffs, and all sort of things that, again, really massively speed up the way teams can work and ship software. So there is a lot of tooling that you can use to build platforms, internal developer platforms. The sort of key thing that we think about in terms of our research at Humanitech is, so what I talked about is the key sort of pillar should be the app config management piece, infrastructure orchestration, and then an RBC model that you enforce through the API. But you can basically plug and play every CI, VCS, any sort of application configuration file or service, any IAC provider. We are actually going to interview next week, in case someone is interested, a guy from a lead ops engineer at Achievers, which is also a Canadian company. And he's going to talk about the IDP that they built using Argo CD. So a more GitOpsy type of IDP than the one that we built at Humanitech. But there's really all sorts of things out there. The key thing is to understand that your platform is the central glue to your to your setup, and is what allows ops to centrally streamline configurations and infrastructure from one place and enforce that throughout all different application development teams, and developers at the same time to self-serve what they need from their setup. And so those are really the key benefits. Now, I'm gonna quickly show you how we think about it here at Humanitech, and how we built our own IDP that we use. The key thing again is to understand there is a sort of like a core API layer that is used to orchestrate the configuration part and the infrastructure, and then that is Humanitech, and that API layer then communicates with or enables configurations through an open standard, which is YAML, and communicates with the underlying setup through open source drivers. And so everything that touches actually our infrastructure is sort of like fully transparent and open source, and something that we're building a community around. And then the sort of the core part is then the only proprietary thing. So happy to, we can jump into this later if you guys want to dive deep into the actual how it works, which I'm happy to do. But do you have any questions until now? Otherwise, happy to actually show you how we think about it. But this is kind of the general theory of IDPs and how how we think about those in at Humanitech. And I can't see anybody, so let's see if I can. Okay, I'll take this as a no question then. Cool. So let me just pull this up. Damn, I can kill this again. Okay, cool. So just quickly, the way again we think about it, Humanitech is basically an IDP has two key users. Is the sort of like the ops user, and then the application developer. The ops basically works from the org settings. This is where you basically want to have a control plane for your ops to connect your whole infrastructure to your IDP. And so you would connect a CI pipeline. In our case, it basically you just generated either a curl or a wget that you're pen at the end of CI, and the platform gets notified every time a new image is built. That way you can trigger all sorts of automations after that. You connect your registries, or you and this, by the way, this is actually Humanitech on Humanitech that I'm going to show you. We then sort of, and again, there's different approaches to this. This is how we do it. We decided to basically have the concept of static and dynamic resources. And so static resources are resources whose life cycle is not controlled by the platform. So that would be, let's say, a production database that you would connect to run your production environments, but the platform wouldn't control its life cycle. But for the dynamic ones, what you can do, and this is where sort of like the golden path comes into play, you can specify different types of environments. So Dev1, Dev2, production, feature environments, and so on. And then say, hey, every time an application developer spins up or uses a environment of type X, automatically provision that with resource Y from cluster Z. And so at that point, the API layer effectively controls the life cycle of those resources. So they're created whenever the environment is spun up, and they're destroyed whenever the environment is sunset. And this obviously, allows us to have a really good control over you know, for instance, environments or resources that haven't been used for a while, but especially it allows us to say, you know, to set rules where we say, here we set the different roles. So you have roles on org level, app level, and environment level, and then say, hey, every time a application developer accesses that environment within that application, within that org, these are the, you know, this is the database, and this is the DNS and the ingress and so on that they're going to automatically be provisioned with, and this is what they can do with it. And so this is that sort of streamlining and enforcing part that's really important to us. Once you've sort of wired up the sort of the whole setup, the application developer kind of view looks like this. So you'd have, and again, this is us. This is our UI. We've seen it. You know, a lot of teams prefer doing everything through a CLI, and so you just have a bunch of commands or just by calling APIs. But the sort of, you know, best developer experience really happens through either the CLI or the UI. And so what we basically, the way we think about it is like, okay, now as an application developer, I can go in here, I can select different images, different image versions for a given container and a given workload. I can change some variables. I can, you know, add a file path, and I can change the baseline configuration that the ops set for me. And so just to reiterate on this, this is this part, right? So it's where the ops can say, hey, I want, you know, every container in the dev1 environment to have 0.3 CPU, and that's what you would see here. And then depending on the kind of you know, rules and permissions that you set for me, I'd be able to change that or not. I'd also be able to add resources and so on, and this is what will be already pre-provisioned depending on what you kind of decide on the dynamic resource side of things. And so, you know, you can add side containers, whatever. So we really try to make it as flexible as possible. Now we are a pretty small team, and so you know, all our backend and also front engineers have access to and can do pretty much everything, not on production, but on dev and staging. But obviously, you know, the RBAC really comes in handy at sort of like for larger teams, where we see it's really important to enforce who can do what in different places of the organizations. And so once you've done that, and you know, you've done your changes, whatever, you know, you can hit deploy. Write a little comment. I'm not going to do that because it was actually live, and then you hit deploy. And when you hit deploy, the platform, basically the API, would take the new variables, the new changes that you made, apply them to the baseline configurations, and then deploy the new generate the new manifest and deploy them. And what that then allows you to do, or what allows us to do, is pretty cool, because then you can manipulate these deployments and you can see you know, a really nice versioning the same way you would with your code of who deployed what, where, when. You can say, hey, if something didn't work with the current running deployment, I could you know, go to a previous one and just redeploy it, or I could do a diff between the previous one and the current one and create a draft from that diff and deploy that. I could also just like clone it to a separate environment. So it gives developers a lot of flexibility to interact with not only resources on a workload level, but also environments and deployments. Yeah, and then, you know, I mean, we also did a bunch of other things where you could, for instance, say a bunch of automation rules. So you could say, hey, every time there's a new image on top of whatever master branch, automatically deploy that. Again, I think the key thing, the key takeaway is that you know, whether it's Humanitech or other sort of like home built IDPs that we've seen is really trying to promote the idea that it's a very flexible API layer that adjusts and connects with all the bits and pieces of the infrastructure to enable self-service and really make it as flexible to sort of like fit whatever needs a team has. So this obviously fits very well our own needs. But yeah, this is kind of IDPs and how we think about it in a nutshell. We've also, I guess I should have shared my screen for that, but I guess I can just copy and paste it here. We have, and this is also the reason why I originally reached out to Steve. We recently launched internal developed platform.org, and that's the repo, sort of like a public repo where we're collecting not just how we think about IDPs, but how the ecosystem thinks about them, how everyone is developing their own. We're collecting all the war stories, different tooling, whether it's open source or vendors. And so I think it's a really good place to start if you're interested in learning more about that. Yeah, that was it. So thanks for the time, guys. And I guess I'll open it to questions. We have 10 more minutes.
Thanks, Luca. That was great. Yeah, if you've got any questions, everybody jump in the chat with a question or raise your hand and we'll get to you. I've got the chat and the participant panel open to keep an eye on that. I've got a question. So if you've got something like a custom Kubernetes plugin, is that going to be surfaced through a GUI like Humanitech? Like, is it going to show up, or is it just going to be buried kind of in the background?
Yeah, so in general, everything that we try to do, and so we're open sourcing right now all the drivers that communicate with the underlying setup, and so everything can be done through those drivers, and we want to do that so that it not only stays fully transparent in terms of what touches the infrastructure and what you know, and so you can see inputs and outputs, but also especially so that you know you can reuse stuff and you can grow that kind of library of use cases. And so that's where you would add any sort of you know, specific thing that you need to do, whether it's on the Kubernetes object level, it's on your Kubernetes cluster, or any other resource. You can just basically fork a driver and use that to specify exactly your needs. Another example would be, you know, for instance, we don't have this use case internally, but a lot of teams need to, whenever they spin up a new database instance, they need to have that preceded with some version of, you know, anonymized production data. And again, the driver allows you to basically specify that in the process of creating that resource. And so that resource would come preceded. And so we're really trying to invest a lot of time on this concept of the drivers and really make it as you know, flexible as possible. And that's also part of you know, the sort of IDP.org site of having just people collaborating there.
That's very cool. So in the case where, let's say, like one we know is going to happen, like Amazon's going to come out with a new service tomorrow. Is that a question of writing your own driver to access that new service? And then that could be, I guess you could probably copy an existing driver that might be somewhat similar to that service and then work from that and then get that onboarded without having to wait for anything official from Humanitech or from AWS to support it?
Correct. And that was precisely the idea behind it, because you know, we were already you know, we were getting swamped really fast by hey, I need a driver for this, I need a driver for that. And as I said, we're a small team, so we don't have the resources to do all of that. And plus, this is already creating a really nice, ecosystems where, for instance, DevOps agencies, for instance, will contribute to drivers to get customers, for instance, and that's great because then they're, for instance, where we just started collaborating with an agency that has a lot of experience in Azure, which we're not super experienced in. We're much stronger in GCP and AWS, and so they're bringing in that experience in the repo, and they're building a bunch of Azure drivers, which is great. So whatever people need, and that also I think is cool because allows people to don't ever feel locked in, and that's the idea of Humanitech, but of any IDP in general. Is, again, as I said, is evolve with your setup, and it shouldn't be something that ever prevents you from. It's the opposite, right? It's what should push you forward, not hold you back.
Yeah, that's very cool. Another thing that I like, I mean, you kind of preceded this IDP pattern, but on the way of like minimum developer platform or minimum viable platform was the idea of like a service catalog, right? And we've got a company in Toronto that started up and it's dedicated towards service catalogs. Where do you see the overlap between something like a service catalog it's collecting, like, here's the service, here's the repo, here's who owns it, here are the dependencies, blah, 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 all that stuff, and something like Humanitech? Like, is there an aim to incorporate that and have that live under the umbrella of something like Humanitech, or potentially integrate with services like that?
Yeah, absolutely. And let me share here in the chat this. I wrote this article a couple of months ago, and actually so this is talking about Spotify Backstage, which is probably the most popular service catalog out there, also open source. And actually, this got us into a call with the whole Backstage team last week. So we were trying to figure it out. They were not sure themselves, and I think there's a few integration points, but basically the key idea of a service catalog is service discovery, and then providing templates basically, and blueprints for services. And so that's great. It's especially great at a large size organization. It's not incredibly useful for smaller teams. That said, they also said they do see a lot of use case. They do see a lot of usage in smaller teams as well. Same as with us. I mean, the larger the team, the larger, the bigger the economies of scale you're going to get. But it works for smaller teams as well. But so the service catalog basically allows you to do the service discovery, the service blueprinting, but it's kind of a step, I guess, higher or lower, depending on how you look at it, from an IDP, where then, okay, now you have your service. Now what? It doesn't actually allow you to run it. It doesn't allow you to deploy it, and it doesn't allow you to sort of provision or connect all the different dependencies that you need. And so that's really where we see the sort of like the two coming together, having basically a layer on top. And this could happen, for instance, in the case of Spotify Backstage and Humanitech, as a UI integration, where you have where basically, I don't know, I mean, if you guys are familiar with Backstage, it works with this UI modules. Humanitech could be one of those modules, and you would then be able to use that to deploy your services just by calling Humanitech API through the service through Backstage GUI. And so that in general, I think, is how service catalog in any IDP or internal platform could work together, where you have an even higher abstraction of your infrastructure with the service catalog, and then from there, if you don't have to get into sort of the details and nitty-gritty of how you want the deployments, which might or might not be your use case, you can just one click call the API, and then that can be configured through a driver, for instance, to again, provision certain things and deploy your apps in certain ways. Obviously, it's going to be less flexible, so you're not going to have a sort of like a full freedom of self-service from the developer perspective, but it allows you to definitely streamline your setup a lot.
Cool. Yeah, I think that it seems like everything these days is being built in a way that you could embed something like Humanitech into Backstage or Backstage into Humanitech, depending on what your workflow wants to be. And that's kind of I like that direction that we're going in, where it really doesn't matter what you want to work in. You can plug things together and it's gonna work at the end of the day. So if I'm thinking of like a real life scenario that I've kind of run into pretty often, it's the idea of like per branch environments, right? So I open up a new branch, I deploy some code. I want an environment that's going to be spun up. And then I want basically like a URL to show up in Slack, like sent to me, or maybe sent to a channel that I'm watching along with the rest of my team. How is that something that Humanitech is kind of built to accommodate, or is that just a potential use case? Like, what would you say is kind of the most common use case that people are using Humanitech for most of the time, and how does it compare to that scenario?
Yeah, that's a great question. So we definitely see a bunch of different use cases. The one that you just mentioned is actually one of the main ones. And so I'll give you an example. So dynamic environments has always been at the core of dynamic, ephemeral, however you want to call them. It's always been at the core of kind of like Humanitech's design. And the idea is that, again, every time a developer can just serve environments, in our case, because we work with Kubernetes, that would be a namespace on your cluster. And so you would one click through the UI or command through the CLI, create that namespace, that environment, and that comes with the URL that you can reference, and that comes with all the resources attached to it. One of the main, at the beginning we had feedback from a few teams, and they're like, well, it's not like I create a new environment every day, but it really depends on what the workflow is. And so we actually now see a lot of teams that have a huge need for dynamic environments, and that really, it's actually really painful to get to if you don't have an advanced sort of like API, because it becomes, we see teams, especially at enterprise level, where it will take them days, literally days, to create a new environment, right? Because it needs to go through a ticket, and and then the ops needs to actually go and provision it, which is the most boring thing, right? It's so boring. You just create an environment, and then you feed it back, you give it back to developers, and so on. And so a use case that we see a lot is for QAs, for instance. So the ability of say, hey, I want to just replicate an issue, or I want to test something, and I want to just recreate this environment with the same variables, and then go and change something there and redeploy there. And so Humanitech definitely.
Oh, I lost your audio. I don't know if everybody else did. Or maybe, oh, looks like it's not just me. Maybe your AirPods died.
I'm not hearing anything here either.
Well, it's 6 o'clock, everybody. Well, I don't know. Maybe there's internet issues. Oh, I hear something. Is that Luca?
Can you hear me
There
now?
we go. Now we got you back.
No.
Almost. One moment.
Now, can
There
you
we
hear me
go.
now?
That sounds good.
Sorry, it's my. I think it was my my AirPods.
AirPods,
Sorry
yeah,
about
that used to happen to me all the time. Luckily, I've been lucky. I've been lucky recently.
Yeah.
Where were we? I got distracted.
Yeah. Anyway, yeah. I mean, yeah. I see people are are
Yeah.
jumping
So
off.
one thing, I think it's interesting that you hear that people are like, I don't want to spin up an environment every day, but that's actually, I think that's going to become more and more common, right? Like that, I think is the good practice, is to have these super temporary environments, spin it up, check the thing you need to check, throw it away, right? Release the resources back. I know a lot of teams keep these long running environments and they get stale and they get, they pick up all kinds of eccentricities, and then all of a sudden you can't re-provision it because it's different than the spec, right? But I think we're going to see that a lot more. One thing that I'd like to see, and I don't know, this is my last question for features on Humanitech and other development platforms, is if we are moving towards this kind of very ephemeral environment, super temporary, is there a way in Humanitech to mandate globally, to say maybe across an entire division of the company, all development environments only last 24 hours and we tear them down? Is that something that we could enforce from a policy level?
Yeah.
Or would
Yeah.
that be up to each individual team? Could we globally define something like that?
Yeah, so you can do both. So you can say, hey, so the roles and permissions work, at least for Humanitech, on an org level, or on an app level, and on an environment level. And so you could say throughout the whole org, which is the whole company or a whole division, you could say, all environments of type dev1, last 24 hours. And then you could say, and then depending on the permissions that the central platform team gives to the application development team, that app dev team can change that through the API, currently not through the UI. And say, well, no, actually we want our dev one to last 2 days. But yeah, it's again, very, very flexible in that sense.
Awesome. All right, with that, I'm going to let you off the hook. Thank you very much for joining us. This was great. I love hearing about development platforms. I love that we had 2 months in a row. We got 2 different perspectives. That's very cool. So thanks for taking the time. I do want to let everybody know that next month we lined up Peter Madison to talk about pipeline security. So he's going to be joining us to talk about securing CI/CD pipelines and different methods for ensuring that you've got a safe pipeline process. So we're going back to CI/CD next month. I hope everyone can join us. And thank you for joining us this month. It's been great to see everybody. Thanks.
Thank you. Thank you.